All cameras' light meters must be calibrated to a standard level of exposure. That level is around 18% grey, and we can consider that the default. Now what I'm showing you here is 18% grey, as you've probably guessed, and it's a well-known tone to most photographers. And I got my 18% grey on a quick Google search. So the exposure meter in our camera is set at a level that suits most photographic situations most of the time. So if we photograph a typical scene in reasonable light conditions, we get a good result. But our camera doesn't know if we're about to capture a very bright, hazy seascape like this, or maybe a snow scene, which is much brighter than normal. Our camera's light meter also doesn't know if we're shooting in the depths of a rainforest, where it's dark and gloomy and therefore would be considered darker than normal. The camera doesn't know because it's just a dumb machine. So any time the light begins to stray away from what the camera would consider normal, we have to step in and help the camera to expose the image correctly. So it follows that we need to have some idea what normal is from the camera's point of view. Now let me demonstrate this with my very inelegant shot from the front of my house. Remember, the camera can only look at various places within the scene and average the exposure over the entire area we're viewing. The camera cannot give one exposure for one part of the scene and a different one for another. It can only be an average, and that brings us back to my earlier statement that practically every exposure will be a compromise. So the camera's normal exposure calibration is around 18% grey. So let's check it out with this image. I'm using my image editor here to first take away all the colour in the picture. And what I've done then is to use Gaussian blur, one of the filters in my image editor, to blur the entire picture. Now we're seeing much closer to what the camera sees. So what I've done in my image editor is basically averaged everything within the image across the entire frame, and what we're left with is a mid-grey. Now let's look at the image alongside the 18% grey that I found online. Now all of those shapes are 18% grey. In photographic exposure terms, the grey of my image and all of these cards is virtually identical. But we can see something else here. We can see that the exposure in one part of the image is better than another, which once again supports the fact that an exposure is almost always a compromise. Now I think it's going to be quite interesting if we expand this experiment a little further. I've selected two images which you've already seen earlier on, both of which I would consider are not normal from an exposure point of view. Let's start with the lighter of the two. Now what I've done here is to first remove the colour from that seascape and then blur it much the same as I did with the image I shot from my street door. And as you can see, we've got quite a light grey on screen. Let's compare this now to our 18% grey. I'm not sure I can find a better way to demonstrate that from time to time the exposure meter in our camera is going to get things wrong. So let's just think through what the exposure meter would have done if we'd left it to its own devices with that seascape. So the exposure meter is looking at my seascape and it's seeing it much as we're viewing that grey background image. And it's saying to itself, wow, this is quite bright, I need to give this less exposure. So it tries to reduce those lovely light tones to the mid-grey you can see in the centre, which is 18%. And the result is going to be an underexposed image, one that's going to be dull, lacking in contrast and therefore appeal. So as I'm standing on the edge of the cliff here, and before I even raise my camera to my eye, my exposure experience is telling me this isn't a normal scene. I'm going to need to give this more exposure than the camera is prepared to give. Now let's check out the exposure of the image we've just been viewing in Adobe Bridge. I can highlight the thumbnail and I can look at the metadata, and this is the area we're interested in. 250th of a second at f8 was given to the shot, but look at the little figure just underneath, plus 1.33. When I shot that picture, I gave the exposure about 1 1/3 stops more than the camera was prepared to give. That backs up and confirms the difference we saw between the image when I blurred it and that 18% grey. Coming back now to my blurred seascape and our grey 18% tone, we can see the difference between the two, which we now know from the metadata was approximately 1 1/3 stop. To finish off, let's take a look at our rainforest. Shot in overcast conditions, and I would emphasize this could be considerably worse if the sun was shining. Let's take the color from this shot and blur it completely to exactly the same level as the seascape, and we can see without comparing it to our 18% tone that we're considerably darker here. So let's take a look at the 18% grey over the top of the image shot in the rainforest. Quite a considerable difference between the two. And let's think through what the camera was about to do. The camera is looking into a dark scene. The exposure meter is saying to itself, wow, it's dark here, I'll give it more exposure, because our camera is a dumb machine and it didn't realize it's supposed to be dark in a rainforest. But let's take a look at the actual exposure of that particular image. Here we are in Photoshop's Bridge with the thumbnail highlighted, and if we look at the exposure up at the top of the screen, we shot this at 1/3 of a second at f8, but look at the exposure. That -1 means that a compensation has been set. In other words, I recognized that the camera was about to overexpose the shot, and I stepped in and used the exposure compensation wheel on the back of my camera to say, no, give it 1 stop less exposure than you were prepared to give. 1 stop less exposure is half the exposure that the camera wanted to achieve. So the scenes we've just viewed are not normal from a camera's light meter point of view. And because our camera is a dumb machine, it doesn't know that one shot is supposed to be excessively bright and the other image pretty dark. And what I would say at this point, although I've already said it once, is that higher contrast scenes will make what we've experienced here considerably worse. Both my light scene and this darker scene would not be classed as overly contrasty. But imagine the rainforest in bright sun. The contrast difference between the water and the shadows and maybe highlights coming through onto the leaves, especially if the leaves were wet, would be much, much greater. So although we talk about the 18% grey and we're referring to an on-screen image, from time to time you may hear me or others refer to an 18% grey card. Why do we do that? Well, because back in our film days, many of us carried an 18% grey card around with us. So if we was in very tricky lighting conditions, we could actually take a meter reading from the grey card.